Okay, so you can call this Notes 2.1 factoring. Now, we're going to be factoring for a while because there's a lot of different kinds of factoring. Okay, there's a lot of different kinds of factoring, and this may or may not seem trivial to some of you, but I always try to just start from the basics. We might go a little bit quicker than you've learned it in the past, but I always assume that, like, you need a refresher on everything. I just always assume that. All right, so let's do a quick review. All right, and I want you to simplify. All right, so this is kind of a review of what you should have seen in the video that I asked you to watch for homework. All right, so we're not factoring yet. We're just refreshing our memory on a little bit of simplifying. All right, so once I get these written up here, I'm actually going to pause the recording so you guys can take a minute and actually do them. And then I will start it back up when we go over the answers. Okay, so Caitlin helped me with this a second ago. Simplifying here just means distribute the term in front of the parenthesis onto each term in the parentheses. Now, when you combine variables, letters that match, okay, with multiplication, it just means you have more of that letter, all right, in terms of an exponent. So in number 1, when I do a times 3a, I still have 3, but now I have 2 a's, but I write it as a squared. A times a is a squared. And then a times 7 is 7a. We okay with that? All right, anybody want to take a stab at number 2 for me? Chance?
Negative 2n to the third.
Very good. Very good. Plus 2m. Very good. 2 negatives make a positive. All right, anybody want to take a stab at number 3? Kevin, you with us there, bud? Brooke? No? Ferris? Good, because I have an x times an x, they go together, but I do have to carry the y with it. Okay, and is it okay if I put the x first and then the y squared? Yeah, his way is okay too. But I will tell you, if you're ever trying to match it up on a multiple choice or something, they'll always be in alphabetical order. Okay? Questions on that? Okay, so then what is factoring? Well, factoring, okay, factoring is just the process of taking something like this, which is called a polynomial, okay, and turning it back into the product of 2 other polynomials, okay? That's what factoring is. So we're going to start with just the kind that where one thing comes out to the front, okay? That's called the greatest common factor, all right? So officially, section 1 of the new material, or, well, the notes, I guess. So we're going to factor each polynomial. That's what it's called when you have all those terms added and subtracted, a polynomial, by finding the greatest common factor. Anybody remember what that's, how you can abbreviate that? Greatest common factor? GCF, good. So from now on, I'll just say find the GCF. Okay? All right, so now that we're into another section, I'm going to start over at number 1. And we're just going to start with the basics and build from there. All right, so GCF means what number and or letters can go into all the pieces of this polynomial? Like divide into it evenly. All right, so what can go into 3x and 12? 3, okay? So because 3 can go into both, that is my GCF. And what factoring does is it has you take out that 3, but you're really taking it out as if you were dividing by it. All right, so now I need to know what's left from each term. Okay? Well, if I take a 3x and I divide by 3, what's 3 divided by 3? 1, but there's still an x. So I don't have to write the 1 if there's something else to go with it, but if you want to write 1x, you can. And then what's 12 divided by 3? 4. Okay? And so that has been factored. Y'all remember this? Do other people remember this? Okay. All right, number 2. (10y squared plus 15y). All right, take a second and think about it. Make sure you're looking for numbers that you might have in common and letters. All right, Grady, what's the biggest number that can go into 10 and 15? 5. Very good. All right. Now, if one of them has a y squared, which means it has 2 y's, and the other one has 1 y, how many can they have in common? 1. Okay, so I can take 1 y out of each. So I'm going to divide my numbers, but I'm really taking away my y's. Questions on that? All right, so I'm going to put up a couple more examples and give you a chance to think about them for a few minutes, and then we'll go over it. Because you should have done this before. This is just a refresher. Okay, so, Keith, what did you take out for the GCF in number 3?
X.
X, awesome. And what was left?
X plus 3y.
You got it. Any questions? Anybody? Okay. Now 14 is a little trickier. There's a lot more going on. Caitlin? 15 is the biggest number that can go into both. 5 is, and you didn't say 5, you said 15, but 5 is a number that can go into both, but it's not the biggest. Okay, you always want the biggest. And yes, they each have a single A and a B that I could take out. What was left over? A minus 2. Rocking it. Okay? Anybody want to take a stab at the next one? Gavin? Good. You took out an X and a Y. And what was left? Good. And one thing you can do just in case, like double check yourself, look at what's still in parentheses and just make sure you don't have more in common. Okay? Because if you do, then that just means you didn't take out enough. All right? Last one. What did you notice? It doesn't have anything in common, right? So the greatest common factor would be the number 1. But if I take out a number 1, does that change the way these numbers look? No. So if you can only take out a 1 and you're trying to factor, we call that prime. Okay, does that ring a bell? All right, I got 2 more because I'm going to throw a few more letters and numbers in there, and then we'll be done with this section. Okay? So I got 2 more for you to think about. I'm going to throw in quite a few more letters. Okay. Lots of X's and Y's. All right. Ailish, do you mind typing in the chat box what you took out of the first one? You don't have to tell me what's left. You can just type in what you took out, if that's easier. X. Yes, that is the only thing they have in common is a single X. All right, so in terms of my X's, I have to take one away from each piece, but I get to leave all the Y's. Now, here's why I wanted to do this problem. What happens when you take away the only thing that's there? You put a 1, very good, because remember, it's divided. X divided by X, well, anything divided by itself is a 1. You have to have that placeholder. Okay? Very good. And Mason, what'd you come up with for number 8 for the GCF? 2x squared. Perfect. Perfect. So what was left over?
3x.
Uh-huh.
7 minus x.
Careful. Minus
Minus y.
to the... Perfect. Perfect. All right. So that's GCF.